having more tools, so having those Pythagorean identities, will make some proofs easier. But having more tools also makes your life a little bit harder, right? If you're trying to fix something and somebody hands you the right tool to use to fix it, life's easy, right? If you're trying to fix something and someone goes, here's Home Depot. It's like, what? Do I have to buy everything here? What do I need? Right? That makes it more difficult. You have more things you can fix, obviously, but you don't need all those tools. So we're going to have to strategize when we can use a tool and when we can't use a tool. So a number in A here. We'll start with A. Again, I want to prove it, so I rewrite the question. Cotangent theta plus tangent theta equals cosecant theta secant theta. I draw the line. And I observe at first. Very good plan in doing a proof is take a look at it and sort of say, what kind of strategy do I want to start with? I cannot use any of the Pythagorean ones. They only work if you have things that are squared. Sine squared theta plus cos squared theta equals 1, but sine theta plus cos theta does not equal 1. It only works if they're squared. I have nothing squared here, so I'm not even thinking about my Pythagorean identities. In fact, I would look at this one. It seems like the basic strategy of changing to sine theta and cos theta will be the best. So I'll start with that. Okay, so cotangent is cos theta over sine theta. And tangent would be sine theta over cos theta. Cosecant is 1 over sine theta, and secant is 1 over cos theta. After changing things to sine theta and cos theta, the next step is get things to be a single fraction. Well, the right-hand side, I can multiply the tops. That'll just be 1. I can multiply the bottoms. Perfect. That's a single fraction. On the left-hand side, I'm adding fractions. How do you add fractions? You would need a common denominator. So this one's missing a cos theta, so I multiply top and bottom by cos theta. This one's missing a sine theta, so I multiply top and bottom by sine theta. That would get me a common denominator of sine theta times cos theta. And in my numerator, I would have cos squared theta plus sine squared theta. Now, in the proofs that we were doing up till now, usually if you change things to sine and cosine and you got a single fraction on both sides, everything was perfect and it worked out and you'd be just like, I'm done. But this one's not quite done yet. We're very close. My denominators are the same. But this one, my numerator is a 1, and this one, my numerator is cos squared theta plus sine squared theta. And you definitely can sort of use the other side. It's like, is there a possible way I could change cos squared theta plus sine squared theta to 1? Absolutely. We have that as one of our Pythagorean theories. You're allowed to just change it to 1. And now make our statement that the left side is equal to the right side. And we are all done. Part B. Second proof. Okay. First of all, this one does look a little bit scary because it has something cubed. And on the other side, I have cotangent, I have cosecant squared, and I have minus cotangent. This one, I would analyze a little bit. Because yes, you can change things to sine and cosine, and you can prove this one. And it will work perfectly fine, but I'll warn you that it will be a little bit long and a little bit annoying that way. If I look at this one of the things I notice is that I have only one thing squared. I'm going to highlight it here. This is the only thing that's squared, which allows me to use one of my Pythagorean identities if I wanted to. So I'm like, maybe that would be a good option. What could I change it to if I changed it? I could change the cosecant squared to cotangent squared theta plus 1. And I look at this and I go, that might be a really good idea, because then everything would be in cotangent. And we saw in an earlier proof, if you can get both sides just with the same trig function, usually that makes the proof even quicker. So I'm going to just test it out. I don't know if it's going to work, but I'm going to test it out. So I'm going to take cosecant squared, I go to my formula sheet, I see that it's cotangent squared theta minus 1. This seems promising because now the right-hand side also is only in cotangent. What can I do? Well, algebraically, if you have something outside of brackets, right, you have to distribute. So we have all of our algebra rules still hold. If I distribute, I get a cotangent cubed. I'm happy about that, and this will be a minus cotangent theta. Oh, and I have a plus cotangent theta. Those will just go away, leaving me with just cotangent cubed. And what looked like a really difficult proof at the beginning was actually quite easy. I just changed everything to cotangent. Things disappeared and it worked out very quickly. And this one, if you change to sine and cosine, would take you quite a bit more time.
Mr. Chair,
Yes.
I'm a little lost as to where the plus cotangent theta came from.
Yes, I am too. Thank you. I wrote this down. Well, that was a minus. It should stay a minus. Anybody see where I made the mistake? On the formula, it's cotangent squared plus 1. I wrote that down wrong. That would have made this plus, and it would still go away. But good observation. What my brain did there was when I copied the minus to a plus, I knew I wanted to cancel it, and I knew it was going to cancel, so I just wrote down the other thing wrong as a result as well. But we should be checking those things as we go, because it's easy to do. If identities are on the exam, okay, I would have, that's a tiny mistake, but I would have lost a mark and a half at least for that mistake. I would have lost a half mark for changing a minus to a plus is a silly mistake. That's a half a mark. But writing an identity wrong down is considered a big mistake. So when I wrote that cotangent squared theta minus 1, they would have said, that's a big mistake, Mr. Jair. Take a mark off for that. And then we take off a half a mark for your minus sign. So what it was initially just a tiny mistake, and then I compensated that tiny mistake by making a big mistake so it worked, that can be dangerous. So be careful, because you will be tempted. Your proof is not going well. And you're like, I'm so close. Maybe I'll just look at the other side and write it down on my side and hope it works. Well, then you usually lose your mark for your first mistake, and then just trying to undo your mistake by making another mistake loses you another mark. So often I say, if you get stuck, it's better just to stop rather than to make mistakes to get you unstuck. And a good strategy on proofs, if you get stuck, completely throw away your, put it off to the side. Don't try to find your mistake, because your mistakes are usually ones that are so easy to make that you'll never see them. You'd be like, I never thought I would change an S to a T, but you changed cos theta to cotangent theta, and you can't see anything else wrong after that. So if it's not working, a good strategy and a proof is to stop. Completely start again, but the second time you start again, go a little bit slower, be more methodical, and hopefully you'll make less mistakes. All right, I'm adding another question. So this is part C. We're going to prove tan to the 4 theta minus secant to the 4 theta equals negative tan squared theta minus secant squared theta. And something that comes up a lot in proofs, and a strategy I'm going to get you to look for, is looking for differences of squares. Because if you have a difference of squares, you can factor. What is a difference of squares? Something squared minus something squared. We have it on the left side. This can be factored to be tan squared and tan squared, secant squared and secant squared. One with a plus, one with a minus. How is this helpful? Well, something in here probably could use the fact that tan squared theta and secant squared theta are connected, because tan squared theta plus 1 is secant squared theta. How we're going to use this is we have to look if there are ways that we can rearrange any one of these factors that matches up with that one. First of all, do you see that if you move the secant squared on the same side as the tan squared, it would be minus. You would have a tan squared minus a secant squared. So I know, looking at this one, the tan squared theta plus secant squared theta, I won't be able to do anything there. So this one, I won't change anything. But this one, I can't get this without doing two mental math, right? If I move the secant to the left, I'd have to move the 1 to the right, which would be problematic, because it's two things. So to show my work here, I might do tan squared theta minus, and then I go to my formula and say I can change secant squared theta to tan squared theta plus 1. If I do this, that negative is going to get distributed. And tan squared minus tan squared is going to cancel, and minus 1 is just going to be a minus 1. And then from here, what can I do with that minus 1? Well, I can distribute that minus 1. And now my left side and my right side are the same. Factoring this and using the Pythagorean identities makes this a lot quicker than changing to sine and cosine. Sine and cosine will still work. It might just take a couple of pages and some advanced factoring skills, which you probably don't want to use. So there are times where the Pythagorean identities make your life a lot easier. What I'd like you to do right now is turn to page 620, because it's a blank page, and I've compiled some strategies. Some of these we haven't even used yet, but there are some strategies. And beside these strategies that I've listed, what I'm going to do is number them. So the number one should be like, usually is your first strategy you go to. Combining trig functions to sine and cosine, and combining fractions, getting a single fractions by getting a common denominator. Okay? Second strategy is looking for our Pythagorean identity. And the third strategy either involves factoring or a technique that we're going to learn tomorrow called build the other side, which has another name, which is multiply by the conjugate. But multiplying by the conjugate, since most of you don't know what the word conjugate means in math, is not a good name for a strategy because you forget it because you don't know what one of the words means. So I call it build the other side. We're going to see that tomorrow. And the last one that doesn't have a number, I'm just going to put a star there. Because that's an important thing all the way through. In fact, sometimes I even use it as a preliminary. You always know what's on both sides of your equation. And that's like a hint. Right? Some of these ones, like when I changed everything to cotangent, it's because the other side gave me that hint. So before I get started, I look at both sides and see, is there any hints this is telling me? Sometimes it won't. Then you'll be like, well, I'm going to go to strategy number one then. I'm going to change everything to sine and cosine and get a single fraction. So being always aware of your goal, what does the other side have? It can often give you a hint. I listed these strategies, but now I've kind of sort of combined them into three things. There's your main strategy of changing to sine and cosine and getting a single fraction. Right? If you want an average of 80% or higher in this unit on proofs, you can usually get that by using strategy one only and being really good at it. Being really good at strategy one is like almost like a guaranteed 80% in your proofs unit. Okay? If you want to get higher than that, or if you sometimes want to make it easier, then strategy two, making sure you know when to use the Pythagorean identities. And then we'll see what strategy three looks like tomorrow.